Hi, my name is Jim Payne, and I'm building a CriCri experimental aircraft.
Yes, I'm building the world's smallest twin-engine airplane.
This is the first video in what I plan to be a series of videos that documents my build process of my CriCri experimental aircraft. Now, this first video, I'm just going to go over the background, the history, what is a CriCri, why am I building one, should you build one, and hopefully I can answer some of the questions that might exist out there for anybody who's heard of a CriCri, doesn't really know what it is interested in learning the history behind it, which is what is a CriCri experimental aircraft. So a CriCri is actually the world's smallest twin-engine airplane. It is a plans-built, home-built experimental aircraft. It was designed in the early 1970s by a French designer called Michel Colombon, and it's had about 3 different designations or 3 different models, if you will, that have come out of the CriCri. From what I understand, the design never changed throughout the 3 different model designations. It was strictly a different engine that was used to power the aircraft. So the initial designation was an MC-10, and I found an article back from 1974, I believe it was, from the Experimental Aircraft Association that did an article on the original MC-10 back in '74. It was powered by 2 10 horsepower, or I think they were actually 9 horsepower chainsaw engines. And then down the road after that, they decided they needed a little bit more power, and they actually ended up using a JPX engine, which was 12 horsepower. So then the MC-10 became the MC-12. Not long after that, the JPX engines were no longer available, and they switched to a 15 horsepower Solo 210 engine, which now changed the designation to an MC-15. So the plans that I have were last updated, last drawn in 1981, and are designated as the MC-15. Now, from what I understand, those are the only plans that are available. They're all the same, so if you do get a hold of a set of CriCri plans, you should have that version, the MC-15, which is the latest version. Now, interestingly enough, the Solo 210 engines are actually still available. You can still purchase engines for the aircraft through Hearth Aviation. They have changed the name of the engine to, I believe it's an F-35, but the Solo 210 that ended up being the 15 horsepower engine used on the CriCri were heavily used. I think it's one of the most widely used paramotor engines that's available. So parts are actually readily available. You can still, like I said, as of last year when I checked with Hearth, you can still even buy the engines for it. So back to the CriCri design. So this French designer, Mr. Colombon, developed this aircraft, and this was developed by a true engineer. Everything about these plans, everything about the design, it's a heavily engineered aircraft. So I don't want to lump this aircraft in with, some of the more garage designed aircraft that are out there. Things like the Teeny 2 or the Hummelbird or the Thatcher CX4 and 5. A great aircraft. I mean, if you want to build an experimental aircraft, I'm not saying anything bad about those aircraft at all, but they were developed in a different method than the CriCri was. The CriCri was developed with engineering first, ease of building second. And by that, what I mean is, if you look at the plans and the way that the CriCri was designed, this is what you would expect this aircraft to be if you sat down a dozen Boeing engineers and their task was to develop the world's smallest aircraft. The CriCri is what they would have come up with. And they would have developed it in a very similar way, using very similar methods, with not a lot of regard to ease of construction. Um, and that's how you end up with the world's smallest airplane. This airplane only weighs 175 pounds. I think the original CriCri MC-10 only weighed 135 pounds. So when you think about that compared to an ultralight aircraft, which has a weight limit of, I believe it's 254 pounds, you can see how far under that even weight limit is. And it's hard for ultralights to meet that 254 pounds in a lot of cases. They're usually stretching every pound they can to try and meet that limit. And here we've got an aircraft that has a top speed of 165 miles an hour. Cruises at like 110, 125. Its flight characteristics are very similar to a Cessna 152, for example, in performance and stall and things like that. And so this aircraft is from an engineering standpoint, I think, unique within the plans built arena, and definitely unique from when you look back at the time frame in which this was developed. It is a all aluminum designed aircraft, with the exception of the fact that the wing ribs within the wings and the tail section are actually foam, a polyurethane or a PVC foam that is actually bonded to the aluminum structure. It's a very highly advanced aircraft, but there's a lot of parts within this aircraft that are difficult to manufacture, especially if you're going to build this aircraft from plans by hand. Now, just to step back a little bit and talk a little bit about the North American history of the CriCri, we have to talk about the North American Cricket. And I want to differentiate between those two names specifically, because in the CriCri industry, you don't want to use the term cricket, especially if you're in North America. I mean, it was one of those terms that was always interchanged because the CriCri was a cricket. Even the emblem and the logo that's on the plans is a cricket. But the cricket name is really associated within the CriCri industry with the kits that were developed by Zenair in the early 1980s for the French CriCri. And the reason it's important to distinguish between the two is that there were some problems with the initial kits that came out by Zenair. Anybody who's building a CriCri or knows the history knows that there were modifications that were made that were unsafe. And the original cricket kits that were built did suffer from flutter problems with the flight controls because of some modifications that were made to the flight control components. And there were several other things that were changed on the aircraft by the kit producer just to simplify the process of providing parts in the kit, and not really to simplify the construction necessarily, but here's an example. I'll give you an example. This here is a fitting that is in the tail of the airplane. This fitting actually mounts underneath the horizontal stabilizer. There's a bearing that mounts in here, and then there's a flight control connection, and this actually moves up and down to move the horizontal stabilizer up and down on the aircraft. There's also some mounting brackets such as this. The original plans were built with the intention that you could buy T-stock aluminum, and that you could just take that T-stock and drill some holes in it and cut it to shape and drill a hole in it for the bearing and drill a hole in it for this bearing, and you would have a part. Well, the fact is you can't buy 2024 T extruded aluminum, at least in this size. And, maybe if you're Boeing, maybe you can get that stuff, but you're not going to buy it from Aircraft Spruce. So this poses an immediate problem when you're trying to build a CriCri, because this is one of the first things that you need to do in the tail is to build these or create these nice little fittings. And so from what I understand, one of the things that Zenair did is they said, well, if you look at this profile, I can just take two pieces of aluminum and bend them into an angle and put them together, and put the bearing in and put the holes in and mount it, and I can have a part that looks like this. It's not going to be nearly as strong. But there were several areas of the aircraft where things were redesigned or re-engineered within the kits that in actuality should have never been done. And what you have to understand with a CriCri is this aircraft was engineered to be as light as possible. So every part is critical in its design because it was designed to be as light as possible with more than adequate strength. But when you start taking parts and swapping them out in this aircraft with something that looks similar, you have to understand that this has very, very tight engineering tolerances. As I said, this was designed by engineers. This was not designed by somebody who just kind of knew how to build an aircraft and decided to just take some aluminum angles and put some pop rivets in it and probably flying just fine. But when you're talking about building an aircraft that is the world's smallest aircraft, which means it has to be the world's lightest aircraft, you have to make sure that the parts that you're putting in this aircraft are per the design. And that's all I can say. Now, with these fittings here, what you actually have to do on this aircraft is you got to go out and buy a solid piece of 2024 aluminum, and you have to mill these pieces. You have to mill these parts. And there's a lot of parts within the CriCri that you have to mill. Every part in this aircraft is tapered and milled, and every ounce of aluminum that they can take out of this aircraft to reduce the weight without affecting the strength has been done. And so this aircraft is overly engineered. I don't want to say overly engineered as in it's heavy or there's too much in it. It's been engineered to be, it's like a Swiss watch. That's what I can say. It's the Swiss watch of plans-built aluminum aircraft. And it needs to be built exactly, or at least as close as possible to the plans. So these are some things that we've had to work around using current modern materials and making sure that we're making things that are made the same as far as dimensionally out of the same materials, and you can build a very, very safe aircraft. So on that note, we're not really going to talk about the Zenair Cricket anymore. I mean, what ended up happening is we had flight control flutter issues because of some torque tubes that part of the flight control system that actually caused vibration. Some things like these fittings were not as strong, and of course the flutter actually caused some of these types of things to fail. And it was a cascading effect. And the end result was is somebody ended up getting killed. Mr. Columbon ended up getting sued, along with, I understand, Zenair, but from what I understand, Zenair wiped their hands of it and said, well, I didn't design this, he did, we just provided the parts. But the fact is the only thing that anybody's ever been able to prove that was ever wrong with it were the parts that were changed by Zenair when the kit was produced. So anybody out there with a Zenair Cricket knows that they need to change and go back to the plans and convert everything that's in that aircraft back to the plans. And I have never heard of a single aircraft that's ever been built per the plans, or that has honestly ever been built outside of a Zenair Cricket that has ever had any issue mechanically with the aircraft. It's a solid design designed by a reputable engineer, and I'm amazed every time I look at these plans at what has been provided to us in the amateur built arena, and that we're actually able to build something like this. It's incredible. The fact that this all happened with Zenair and the kits, it makes me sad to think what we could have had here in the United States, because what ended up happening is Mr. Columbon was sued. He was very frustrated with our North American legal system because, honestly, how could he be sued with a kit that was produced by another company who deviated from his design, and it was those parts that failed? He should have never been sued in the first place. And from what I understand, this may not have happened in France. I don't know. I know we have a very different legal system here. Our freedoms make it so that we have the ability to sue anybody for anything at any time. And in certain cases that's good, but in other cases, like in experimental aviation, it's not good. But what happened then is, of course, we have not been able to get plans for this aircraft here in North America, period. Mr. Columbine has basically said, North America, if you want plans, sorry, I'm not selling them to you. I don't want the legal liability. But what's happened now, over the last 15 years probably, plans have become available through eBay, through there's even sites I've found where you can download PDFs of the plans for free. I'm not going to provide those links. If you want to go find that information, that's up to you. I'm not in the plans business. I'm not going to sell plans for this aircraft. My understanding from the designer is that, he had told people at one point that he had just hoped that the plans in North America would become shareware at some point. Well, they basically have. And again, I don't know if that's true or not. Most of the stuff that I know about the CriCri has been, discussed in forums related to the CriCri and passed on from one person to another. I've never spoken with Mr. Columbine before. And so what I'm hoping to do here is I'm building this aircraft in North America, in the United States. I don't have any resources here. There used to be resources in Europe for landing gear components, for wheel pants, for wingtips, tires, wheels, and brakes, fuel tanks, formed canopies. None of that is available here in the United States right now. In fact, you're not likely to have seen a CriCri at an air show until recently. Last year, 2019, I believe it was, Oshkosh, the French CriCri aerobatic team did come to the United States. I'm sure people saw that in the air show and probably wondering what it was, because, like I said, in the 80s, I used to see some CriCris that were being built because, again, the Zenair kit was around and there were some that were constructed. They would show up at the air shows and be on display next to the BD5s. But they really disappeared after that. Again, you couldn't really buy plans. This availability of plans over the internet at that time didn't exist. And so your only option of getting plans for the CriCri was to either buy them from somebody else who had a set, buy a used Cricket, or talk to somebody overseas in another country who would buy them for you. I do have a set of plans here. I bought them off of eBay 10 years ago. I've since found out that they are copies of a set of plans. I was supposed to get manuals. I didn't. I ended up getting plans off of the internet through PDFs, and that's what I've been using to build my aircraft, and they are complete. The plans I have in a box here are identical to the ones that I have in PDF form. So the plans out there, if you find them, if you can get them, if you can download them, they are complete. There was only ever one set. There was never a plans for the Zenair Cricket. The only thing they did was provide the CriCri plans and then provide addendum sheets to that with the modifications and things that they had done. So that's basically the history of the aircraft, and a little bit about the Zenair side of things. It's too bad that whole situation happened. Like I said, I think we'd have a different environment here in the United States with the CriCri being very popular. Had that whole incident not happened. But I think now is a good time to possibly try and bring back the CriCri a little bit more to the United States. Like I said, I'm comfortable that it is a well-designed, well-proven, safe aircraft as it was engineered. And I believe the plans are accurate. There are some changes in things that we'll show you throughout. Some things are not available, such as some issues with the wing spar caps that we'll go over, and there's been some modifications, just placement of rivets in a certain spot. Those are things I want to document here for anybody else who's building this aircraft, things that will help you along the way. I'm also hoping to provide parts for the CriCri. If I mold a fuel tank, I'm going to make fuel tanks available. If I am able to make a canopy or make wheel and brake systems, I've done extensive research already on what wheels and tires and brakes that I want to use on the aircraft. and I'm planning on making those available. I can also make wing spar kits, completed wing spars, things like that. I do have CNC equipment here, and I'm doing all of my work on a 4-foot by 8-foot CNC router. So all of the parts that I'm producing here that are sheet parts are going to be cut out on the vacuum table CNC that I have here. I've already cut a bunch of stuff out already. I've also cut out the wing spars which need to be tapered. They're 8'6" long. There's 8 of them. They have to be tapered, drilled, milled. There's all kinds of processes. I've done all of those on my CNC machine. And what I'll do is when I start going through the build process in the shop here, I'll show you exactly what I've done and how I've done it. If you want to recreate it yourself, if you have CNC equipment, and you want to build a CriCri, hopefully this will help you out. If I can provide parts for anybody who wants to build one but doesn't have the equipment. And like I said, there's things like these fittings here. You have to have a milling machine or you can't make these. Now, I made these. I bought a cheap Harbor Freight mini mill, and I milled these components on my mini mill. Now, I did some modifications to that mill, and I'll probably show you some of that later on. I added a Dro system, which makes it so that all the backlash and everything isn't an issue. And you can make very precise parts on a mini mill, and it's not an expensive piece of equipment. You don't need CNC equipment in a mill or a lathe to be able to make the parts for yourself if you want to. The big benefit of the CNC equipment is with cutting out like the sheet parts. I can cut out parts and pre-drill 16-inch holes in all of the spots on here's an example. So this is a piece of the tail. So you can see I cut this out on the CNC machine along with dozens of other parts that came off when I cut a sheet of 16 thousandths aluminum. And I pre-drilled these holes. This is actually a plate that mounts in the center of the horizontal stabilizer. These actually mount on either side to support the horizontal tail. Similar to this. This is actually a doubler that goes over the back, or it goes over the front of the horizontal stabilizer spar. So anyway, again, here, this is a bag full of parts that are used on the wing spars. These are the stiffeners that you actually end up. These get bent. These get bent at 90 degrees, and you rivet them to the spar web on the wing spars, and you actually attach the foam ribs to these when you're building the wings. So there's like 54 of these in a bag here that I made. Again, these are cut out on the CNC machine. They're all pre-drilled with 16th-inch rivet holes. And the benefit of that is that the holes are all marked. So even though they're not drilled to the final dimensions, I don't have to measure anything. And these holes actually are in my wing spar webs so that they line up. So I can actually go through and just drill it with a 3/32 bit for the 3/32 rivets and Cleco it in place, and it's ready to go. So there's benefits to having the equipment if you have it to be able to do this kind of stuff. Now, I am using CNC equipment to build my aircraft, but I can guarantee it's not saving me any time. I'm doing it because I enjoy the CNC work. I enjoy playing around with the machines and the equipment and doing the drawings, but when you consider all the time that I have into setting up that machine, doing the CAD drawings, doing the cam, mounting the parts in that machine and getting them cut, I probably could have cut one set of everything by hand. So this has just been a hobby thing that I've been interested in on two sides, not only building the aircraft, but working with the CNC equipment that makes it so that the two go together well. And the benefit of it is once I have the drawings done, once I've cut parts out of it, I can cut parts out for other people if they want it. So I think, so let's discuss a few more things. So why am I building a CriCri? Because you look at it, it's a tiny little airplane, world's smallest twin-engine airplane. But it has some benefits that, and some drawbacks that other aircraft within the experimental realm don't have. So, for example, I had a list of things I was looking for for an aircraft to build. I've worked on aircraft before. I'm a licensed A&P mechanic, certified electronic technician, and private pilot. So those are three things that I had an interest in early on in my career. I was an aircraft mechanic for a while. I enjoyed the work, but I ended up moving out of that area with the electronics degree that I ended up getting, got me into computers, got me into networking and working in an IT environment, which got me into programming, which, I've been doing programming now for 20 years. But I've always still had an interest in aviation. I've always wanted to build an aircraft. And when I started looking at aircraft to build, number one, I've got kids, I've got a wife, I don't have any money. As most people who get into that family environment, I got my pilot's license before I got married. So I needed to build an aircraft that was as inexpensive as possible. And inexpensive, it's not only inexpensive in the cost of the aircraft, it's an expense in the maintenance, and it's an expense in the storage. So when I was looking for an aircraft, number one, I wanted something that I could trailer and keep in my garage, which meant it had to have removable wings. And I didn't want something that was, removable wings that you should only remove once a year. I needed something that popped in and popped off on a weekend. Just go out to the airport on one day, put the wings on, go for flying, and put it back in the trailer and take it home. I needed something that was plans built because I couldn't afford to spend $50,000 on a kit. And the third thing is I wanted it to be aerobatic. And when you start getting in looking at aerobatic aircraft, that's a whole nother level of cost, because most aerobatic aircraft require, a Lycoming Continental engine, something like that, that has an inverted oil system. You're getting into big money then for an engine. It's $35,000 for 4-cylinder, goes up from there. And the neat thing that I liked about the CriCri is it actually fit all of the requirements. It is aerobatic. It has removable wings. It's super small. It can fit, in a trailer. And having a two-seat in this environment was not a requirement for me. I'll go fly a Cessna 172 with my wife if she wants to go with. So single seat was all I needed. And this was the motorcycle. This was the toy, in addition to possibly being able to fly, Cessna 150 and go on a travel somewhere. So the CriCri, I really stumbled upon it after doing a lot of research, and I didn't stumble upon it right away because it wasn't around. I had been using, Kit Planes magazine and looking at all the plans built aircraft, all the kit built aircraft. When I stumbled upon the CriCri and started looking into it, I was like, hey, I know what that is. I've seen that before, because, of course, I'd seen it at Oshkosh in the 80s, parked next to the BD-5s. I didn't think much about it. Of course, as a kid, I thought the BD-5s were really cool. I was looking at a CriCri, which I thought was kind of weird looking. Little airplane that was like, oh, okay, what's that? No, I don't care. There's a BD-5 jet right next to it, so who cares? So, and of course, I would have built a BD-5, had I had the money to. So the CriCri for me is the ultimate airplane. It fits everything in my criteria. There's a few negatives to it. Because it's the world's smallest aircraft, it cannot have the world's biggest pilot. From what I understand, the weight limit really for the pilot is about 175 pounds, which is supposed to be the average male adult. So you really shouldn't have a very big pilot in this without going over gross weight. You weigh more than 175 pounds, you're supposed to start leaving fuel behind. You're talking about an aircraft that only carries 6 gallons. So you're not going to save a lot of weight in leaving fuel behind. So that's probably the biggest drawback of the CriCri aircraft is really the pilot requirements. I mean, it's kind of nice because I'm able to go on a CriCri diet, get down to CriCri weight, which is important, if you're planning on building this aircraft. The other thing you do have to be worried about is if you start building a CriCri that, if it takes you 10 years to finish it, that you might not be the same person you were when you started. But anyway, so I'm hoping actually to build my aircraft as quickly as possible. I do know that I have a lot of stumbling blocks, such as, fabricating a canopy and fabricating a fuel tank and things that are going to be time consuming, not difficult. I mean, there's a lot of documentation on, creating anything you want. It just takes time. You got to create molds and forms, and things have to be done right. So that's why I'm building a CriCri. I'm hoping during this process to document the CriCri in video form. I'm going to walk through every single thing that I'm encountering with the construction of this aircraft, so that it's documented not only what I've done, but what's the acceptable practice for any minor changes that are done just because of material requirements, like these fittings. This is a modification. The original design was to buy T-stock aluminum and to make these parts out of extruded aluminum. It's not available, so you have to use bar stock. Now, this bar stock is totally suitable as a replacement for extruded aluminum, so I'm not doing anything here, and nobody else is doing anything here that is not an acceptable practice in aviation. So those are the types of changes that we are having to make during the build process. Nothing that I am changing is to improve the aircraft or redesign the aircraft because I want to build it easier, or just, nothing like that. The actual final result has to be at least as good or better than the original design, without adding any weight. And like I said, there's only a couple places in the aircraft where there are questionable things that need to be looked at, just because this was an aircraft that was designed in 1970s and it's now 2020. So let me explain also what I've done so far. So I started this process, and I started this process not following the order of build within the plans. And by the way, these plans do come with manuals, not only a step-by-step construction manual, but also what they call a general operations manual, which actually walks you through chapter by chapter on how you should bend things, how you should finish things, how you should glue things. It actually walks through all of the knowledge that you need to build the airplane is in the general operations manual, explaining the techniques you should use, the processes you should use. Goes over the designation of rivets and bolts and bend radiuses and how you should bend this part and how you should finish this part, so that when you get to what's called the special operations manual, that actually walks you step by step through the steps of building the aircraft, that you're able to build this aircraft properly. The other areas where there's some things that need to be changed is the glue. So the epoxy glue that was used originally is really not available anymore. The techniques that were used in 1970s with using a primer and using glue, there's I think better methods available now with better glue and materials that are as strong or stronger than what was originally depicted in the manual. And these are areas where you can vary it. You're not redesigning it or re-engineering it in that sense. So we're going to go over a few of those things too. Now, as I said, the first step within the special operations manual of building this aircraft is that you fabricate these tail fittings, and that you actually build the horizontal stabilizer on the aircraft first. The reason that is the first step in the process is that the thought is that construction of that part, so it's the entire horizontal stabilizer in the back, the construction of that part has a lot of methods that you learn that you will use throughout the rest of the build process. The other thing it does is it gives you the ability to actually finish a part. So, and it's not that difficult to do. It's not, you do have to make these fittings. That's one of the caveats that, you have to get past. But once you build the spar on that, you do the riveting on that, you create the ribs that need to attach to that, which are foam. You create the wing skin, you glue that together, and you finish it, and you're like, wow, look at this, I made something. And like I said, the techniques of making the spar and riveting and gluing and doing all those things, these are all practices that once you've done on that part, you can carry throughout the rest of the aircraft. The only issue that I had with starting with that process was that once you finish that horizontal stabilizer, and the next step was then to do the rudder and tail, and then move on to the wings, you're making all of the parts that are susceptible to damage around your shop. And so I didn't want to start off with finishing, the final exterior of wings and horizontal stabilizers and rudders and vertical fins on the aircraft that I'd have to store somewhere once they're complete. And I started working on the fuselage because I was worried about them getting damaged. I was worried about something falling on them. I was worried about them falling over. And if you look at the process of building this aircraft, it can take years, depending on how much time you have. And so you're potentially going to store, for example, that horizontal stabilizer for an extended period of time, and it could possibly get damaged. The other issue is that you really can't get too far on the fuselage until you finish frame 4. Now, frame 4 is the wing spar carry-through. So the wing spars that connect to the fuselage go through frame 4, and you can't build frame 4 and finish it until you have the wing spars complete. So what I elected to do was to build the wing spars first. By building the wing spars first, I can finish the frame 4 of the fuselage, and then I can take the wing spars off. I can store them anywhere I want. They're probably not going to get damaged. I don't have to finish the wings and put the wing ribs on and put the wing skins on and everything because they're a separate component. In other words, once I have the wing spars done and the carry-through done, I don't have to finish those wings until the last step if I want. And then I can move them around. I can store them without worrying about them being damaged. The same thing with the horizontal tail. The horizontal tail, once you get it done, you don't need it on the airplane. It's better, I think, to maybe make the horizontal, the horizontal spar, because that attaches to the vertical spar that then attaches to the fuselage. Get those components done, but you don't have to finish the horizontal elevator or horizontal stabilizer until a closer process in the end. Because I really wanted to start on the fuselage because that's where all my time's going to be. I got to design landing gear. I got to, you got engines you got to fit. You got electronics you got to fit. You got the fuselage itself, which has tons of parts in it. You got all the flight controls that have to mount inside there. You got the seat. You got the canopy that now has to be designed and fit on there. So I really wanted to get as quickly as possible to the fuselage part of it, knowing that I could go back at any time and finish the wings. Or I could do that in parallel. If I'm stuck on something or waiting on something on the fuselage, I can go back and work on the wings. I can go back and work on the vertical or horizontal tail, or finishing the rudder, things like that. And this gave me the ability of the flexibility to work on more than one thing at a time. So that's my plan. It was to actually work on the wing spars first. Now what I've done is I've cut out the wing spars on the CNC machine, and I'll show you that in the next video. I have gone through the process of milling all of the wing spars, and I'll go over that process too because there's several steps. And honestly, I got a set of wing spars that I scrapped already because it didn't work out. Because I had learned from the process, because the wing spars are the one place where there are some tight tolerances and issues that have to be looked at, especially when working with the CNC equipment. And the materials that are available today. So that's one of the first things I'll go over to, because like I said, it is one of the areas that has to be worked at cautiously. And there's some changes that have to be made to the plans in order to get things to fit properly. And they're just things that aren't in the plans that list some of those things out. Some placement of a couple of rivet holes, things like that. And it's not really that it wasn't designed properly. One of the things that Mr. Columbine did after the fact is, since the aircraft was being used in aerobatics heavily, and they did some testing on the wings, they found out that if they put a doubler on the lower part of the wing spar caps, that they could increase the fatigue time by a factor of 10. So one of the mods to do the aircraft is to attach this this doubler piece of aluminum on the lower spar caps, but you find out that when you start fitting the wings together in the frame 4 center box, that some of the rivets start hitting the parts of those doublers that are put on there. And so if you don't compensate for that when you're building the spars, you can run into problems that are difficult to fix afterwards. And there's fixes that then you can do up front that prevent you from having fit problems later on. So anyway, I think that's it for this video. Look forward to the next video. That's where I'm going to show you the wing spars, show you where I'm at with that, and then we'll start moving through the process, on future videos. So thanks for sticking around.